Hi, everyone. My name is David Padilla. You can find me on the internet through my nickname, David. That's my Twitter handle, my GitHub account, and everything. And I run a company called Crowd Interactive. We're based in Mexico, and we're probably the largest Ruby team down there. And unlike most of the companies at RailsConf, we're not hiring. The other way around, you can hire us to do your Ruby work. We also believe in training, not poaching engineers from other companies. I don't really understand why all these companies are spending money on hiring annoying recruiters when they could be spending money on sponsoring these kinds of events, local user groups, or even scholarships to bring people from college to these events and, give some awareness of what we do and why they should follow a career path and build more Ruby developers. Our little grain of sand that we put to try to do this is called MagmaConf. We run a conference in Mexico, sadly the only Ruby conference down there. And it's going to be awesome this year. You should probably come. We'll have Santiago Pastorino, Greg Pollock, and Brian Lyles. We're going to put them on a ring on a death match. It's going to be awesome. It takes place in the beautiful town of Manzanillo, Mexico. It's coming June 5 to 7. You can find more info on our website, or you can just ask whoever you find with this T-shirt. They will be glad to give more information. Enough of that. My talk is called From Rails to the Web Server to the Browser. Let's talk about the life of an HTTP request, especially when we're talking about a Rails app. The first thing that happens is that a user types in a URL in their browser, and then the browser turns that into an HTTP request. The HTTP request is sent to the web server. The web server does its own processing and sends it over to the web framework. And then the framework, with its spaghetti of code, it's processes this request and then turns that into a beautiful HTML document. That HTML document goes back to the browser, and then the browser renders whatever it's on the document. So you could put it this way. A request is the interaction of these three entities, browser, server, and framework. My talk is about the arrows that you see on this diagram. What's the Ruby code that makes that possible, that interaction? Let's begin by talking about the arrow on the right side. The thing that makes this possible, the communication between web server and framework, is called Rack. Rack is a library that works as an interface between servers and frameworks. That's its job. It's sort of an agreement between all web servers written in Ruby and all web frameworks to use the same code to communicate each other, and that way they can all play nicely. It doesn't matter if you use Unicorn with Rails, or Puma with Sinatra, or Thin with Padrino. They all work, and it's because of Rack. It's a standard. And it's actually pretty simple. The only thing that you need for this to work is a single point of entry, which is a class that responds to the call method, receives the request headers, and then it agrees to return an array with these three elements: the response code, the headers, and the body. And the only thing that, the only other requirement is that this HTTP code is an integer. The headers that are returned in a hash, and the body responds to each. This used to be, the body responding to each used to be very simple back in the Ruby 1.8 days, but String stopped responding to each on Ruby 1.9, so you have to do tricks to make it work, but we'll see more of that later on. So this means that somewhere on the code of the web servers of Thin, Puma, Unicorn, whatever, there's this piece of code. At some point, you must send headers to the application object using its call method. And somewhere on the application side, it's that method implemented, and it returns this array, three-element array. The only other thing that you need to make a rack application work is a file called config.ru. And this file just basically has the information required to start the server and run the application. You could actually put all your Ruby code in this file and make it work, but that will be nasty. So what you do is just require files, and the only thing is you say, yo, rack, this is the object that you're going to use. Send all the information to that instance. Let's create a quick example of a rack application. Like I said, all you need is a class that responds to the call method and returns an array of 3 elements. The only other thing that you need is the config.ru file. You specify the load path. You require that file that I created earlier, and just tell it to run using an instance of that class. To start a rack application, use the rackup command. All you need to do is run that command on a folder that has a config.ru file, and it will automatically start up your server by default on port 9292. Now, let's take a look at what Rails does. First of all, you're probably very familiar with this command. The Rails new command creates the skeleton, the basic skeleton of your app. And I don't know if you've ever noticed on that skeleton, if you take a look at the files that you get, you will notice that there's a config.ru file. And that is because all Rails apps are basically rack apps. All Rails applications are rack applications. And if this is true, that means that we can use the rackup command to start a Rails application instead of the Rails server command. That is true. You can use rackup on any Rails application, and it will start. Again, default port 9292. Don't be confused about that. Now, let's make a Rails application do something. We're going to add a controller. Since let's play it by the book, and this controller, the only thing that we do is just have an action show, and it will render text, guess what? Hello world. Very basic stuff here. The only other thing that we need is a route. So we'll just use the root route to point to that controller and that action. Simple stuff. Let's start up our server and use curl to figure out if this is working. There it is. Just as expected, we get the text hello world. Now, because we're conscious and we use TDD, let's create a quick test for this code. Test is very simple. We're just going to use the net HTTP library to fetch whatever that server is returning and assert that it's returning the hello world text. If we run our test, we'll see that the test is green, it's passing. So we're in a good place right now. Now, for my next trick, I will use the pry-gem. I don't know if you've used this, the pry-gem. You should try it out if you haven't. The only thing that you need to do is add it to your gem file. And when you add specifically the pry Rails gem, what you get is that whenever you start a Rails console, instead of getting the plain ERB console, you get the pry console. And what does it do? Well, it has a lot of nice tricks. Pry works sort of like a shell, like a normal shell. You can CD into an object. That means that when I CD into the Rails application object, the context automatically changes. So right now, I'm sort of inside of the Rails application object. You can do ls, And what you get is a list of all the methods available for that particular object. As you can see here, if we zoom a little bit, we'll see that there's the call method, which is what we're looking for. That must be the entry point for any Rails application. Another neat trick that you can do with Pry is that you can use show method, and it will show you exactly the piece of code that runs whenever you call that method. And it will even tell you where's the file, the line, and all this relevant information. So really try it out. It's pretty cool. Now, we found the call method. Let's try it out. These 3 headers are the minimal thing that you need to make a rack application work. You know, you need to tell it the method of the request, in this case, get. You need to tell it the path. And you need to pass a rack input object, which is the stream of the request. But in this case, we can just use an empty string, and it'll be fine. So technically, if I send this to the call method of the Rails application object, it should return an array with these 3 elements, because that's the agreement that we have when we use rack. We go back to our console, and let's try that out. I'm going to put in the response variable whatever the call method returns by passing those 3 basic headers. And what I get is something, a lot of code. But it's, you can appreciate, but it's actually an array. Let's see. Let's take a look at the first element of that array. We see that we get the status of the response, and it's an integer. Cool. If we take a look at the second element of the array, we'll see that we get a hash with the headers of the response. And if we take a look at the last element of that response, we'll see that we get the body of the application. And since it responds to each, we get it right there. Now, let's go back. This is the way Rails does it. That's, like I said, that's the entry point for all Rails application. And the Rails.application object, that's who responds to call. And web servers just send the request over there and allows Rails to take care of it. Now, let's go back to the small rack application that I wrote earlier. And let's make it do something. So we will have the content, same thing, hello world. We're expecting it to return the status code of 200 as an integer. And we're going to ask it to return the minimum header that a web server needs in order to understand what's going on, which is the content length. If you don't pass that content length, then it will scream at you. And we're going to return the array with those 3 elements. So we're going to wrap the content actually on an array, because remember that it must respond to each. And a string in Ruby, after 1.9, it doesn't respond to each, so we need to do something about that. In this case, I'm putting it in an array. The right thing to do, you don't do this in production. The right thing to do is to use the string IO object, but it's too long to fit on the slide, so we'll just use the array. Start our server. Let's run our little test that we had earlier and see if that's still green. And it is. So that means that this little piece of code, this rack application, is doing the same thing that the Rails application was doing, except with fewer lines of code. Now, let's talk about the other side of the life cycle of an HTTP request. What's the code that makes this happen? Communication between the browser and the web server. A warning is that this is where we go down the rabbit hole. This code is not simple, but let's try to see what's going on. In theory, what we're looking for, somewhere on the web server, we need to see code like this, code where you're passing the request to the application object and calling its call method. So let's try to figure out. And we're going to take a look at the code of thin, because it's relatively simple, written in Ruby. So let's begin there. Whenever you want to start a theme server, you use the theme command. You do theme start, and the web server is fired up. Now, the theme command, what it's actually doing is just calling this method right here that's defined on the theme server RB file, which is just calling the start method on the server class and passes over the binding IP address, the port where you want to start the server, and the instance of the application object that's going to receive the request. If we take a look at the code of the start method, we'll see that the only thing that it does is, well, first of all, it raises an argument. If you don't have an app, it will scream at you. And then it will print, if you're familiar with Thin, you will see that it prints out that basic information about the port and binding address and all that. And then it calls start on a backend object. If we dig around the same class, like the server class code, we'll see that what the backend is. And there's a method called select backend that is just assigned to that instance variable. And if we remove the clutter, we'll see that basically the only thing that you do is pick within these three different kind of backends. Swift apply, a Unix server, or a TCP server. Since it's the most common, we'll take a look at the code of the TCP server class. If we take a look at the TCP server class, the important thing to notice here is the connect method. And the connect method is what fires up the actual TCP server, and it's using EventMachine. I don't know if you've ever heard of EventMachine. It's a pretty awesome library. From its website, it's an event-driven IO library for Ruby. Long story short, it starts servers on a specific port, and then it allows for you to do something with whatever data you received, and it's event-driven. That means that it only needs a class, or a model in this case, that defines different kinds of method. In this example, you can see that there's a method post init. Whenever a client is connected, what do I do? There's the method receive data. Whenever I receive data from the client, what should I do with that data? And another example is the unbind method. Whenever the client is disconnected from my TCP port, what should I do? And the only thing that you need to start a server with EventMachine is the line at the bottom. Just tell it where the binding IP address, the port, and the class of the object that's going to listen to events. So if we go back to the thin code specifically, we'll see that they're starting a server right there and passing host, port, and a connection object. So let's take a look at their connection object, which is defined on thin/connection.rb. Promise I'm getting to the point. Be patient. I'll be there in a minute. So like I was saying, we go and check the connection class, and it's defining the receive data method. The important thing to note here is this line of code. It will process the request if the request can be parsed. We're introduced to a different kind of object, request. The thin request object is in charge of taking a request per se and turn it into something that Ruby can read or can use. It's defined on this file. And its most important job is to parse the HTTP request and turn it into something that Rack understands or something that Ruby understands. And this parser is nothing more than a wrapper of a parser written in C called the Mongrel Parser. And if you take a look at the Mongrel Parser, you'll see that it exists since 2005, and it was written by Seth Shaw. I don't know if you know Seth Shaw. He's famous for calling us a ghetto. I don't know if you knew this, but if you hate him, please notice that you're using his code, because This parser is the same parser that's used on almost all of the web servers. It's used on Puma. It's used on Unicorn, although it's their own version, but the core is the same. So thanks, HR, whenever you get a chance. Now, like I was saying, the job of this parser is to take this request and turn it into something that we can use, that we can actually use to send it over to rack. So let's try it out. We're going to fire up a console, require thin. We create a new request object. We use its parse method, and we pass over the request itself with carriage returns just to make sure that it's all working. And after it parses, it returns true, and we can take a look at the env method, and it will return something that we can use. This is a hash with the request headers, and like we saw in the earlier examples, it's the request method, request path, and more things that it added into it, but it's the basic thing. So that's the job of the request side of this piece of code. Now let's see what happens after we parse a request and we actually process it. So we go to the process method in the connection class, and we see that there's a little difference whether it's threaded or not, but the code is the same. The process method post-processes whatever it pre-processes, whatever that means. Let's take a look at the methods. Pre-process, a bunch of code, basically just adds the IP address and more headers, whatever is needed to the request. But the important thing to note here is down here, we'll find what we're looking for. The code that actually goes to the application object, sends whatever the request object parse using the end method, and returns that into a variable called response. That response, like we agreed on, it should be an array with the 3 elements, status code, headers, and the body of the response. And then I think we'll just use the post-process method to turn that into a proper HTTP request, which is, this is the format, right? So we get the array, and we have to turn it into this, so the browser can actually understand what we're trying to tell it. Let's talk about Unicorn. Does it use EventMachine to listen to ports and stuff? Nope. Unicorn, in particular, uses a Ruby I/O library kind of implementation called KGIO. I didn't try to add code about that in this presentation because I found it just too complicated to do so, and we won't have the time, so you have to trust me on this one. Thus, Unicorn eventually calls the call method and passes the request to the application object at some point. Yes, it does. Like I said, we're not going to dig into the Unicorn code, but if you're curious about it, this is the file and the method that has that call to the call method. Does it use the Mongrel Parser? Kind of uses the Mongrel Parser. They have their own version of it, but like I said, the core is the same. And the same happens for Puma. Same thing. It doesn't use EventMachine. I think they also use Ruby I/O. And they do have a call to the call method on the application object. And that's basically it. So let's see what we learned so far. We know that a web server like Thin does its thing to start listening to connections on a specific port. Then the browser comes in and sends the HTTP request to Thin. Thin takes it and turns that into a hash, something that rack can use. And then sends it over using the call method of the application instance to the web framework. And then the web framework does its magic and then returns the array with these 3 elements. those elements are then parsed again by the web server, and they turn it into an HTTP request. And then the HTTP request is passed to the browser so it can render it. So using what we learned, let's roll our own web server. First, we're going to create a server file. And we're going to add the load path, require EventMachine, and just create the model that implements the receive data method. Code at the bottom simply starts the server and tells it to start listening on port 9292 and use the model defined at the top to process whatever it gets. The only thing that this will do is just print out whatever you get. Let's see what we're getting. So we start that server, and we run the test that we had earlier and see what happens. What happens is that on the server side, sorry, that was premature. But what you get is the actual HTTP request. Wait for it, wait for it, wait for it. There it is. So that's what receive data actually gets, and it's just printing it out for now. Now let's do something with that request. Let's use the theme parser to actually parse that and turn it into a hash that Rack can use to do something with it. So this is what we'll do. We'll just parse the request, whatever comes on data, and we're going to just print it out to see what we get. We start our server. We run our test. And by going back to where the server is running, we see that we get the hash. So the request is now turned into a hash. Next thing, let's add an actual, let's pass it over to the Rack application. We create an instance of it and expect to get a response from that in those three elements, status, headers, and body. And we'll just print headers and body. So if we run our code and we run our test, we'll see that we get exactly what the Rack application is doing, just that content length header and the hello world thing. Now it's time to turn what we have into an HTTP response, something that the browser can actually understand. So we just take our response. Sorry, we create a response variable. We add the head of the response, HTTP1 and status code. We add the headers. We go through each one of them and add them on this format, header, semicolon, value. And then we just add the response, same thing, since it responds to each, then we can iterate through it. And last thing, we tell, using the send response method, we tell EventMachine to please just send that and close the connection with the client. Let's start our server and run our test, see what happens. The test is passing. Cool. We have a running web server that's using that Rack application and still doing what we want it to do, respond hello world, because that's super useful. Now, in theory, we can grab the Rails application that we had and mount it on this server that we just wrote, and we should have the same results. So let's try that out. We edit the file. Instead of using the current load path, we use the Rails app folder. We require the Rails application by requiring config environment. And then on line 12, we change, instead of using an instance of app.new, we use the Rails application object that's generated. We start our server, run our test, and it passes. So we connected the Rails application into our little web server. Little piece of advice, do not try this at home. More like, do not try this in production. Web servers exist for a reason. Web frameworks exist for a reason. So you don't want to do anything with this. Just play around with code, and that's it. Which is my second advice, be curious. This talk just came out of me just wanting to know what's going on inside, what's turning whatever we put on the browser and on the Rails side, and then just what's processing, what's the Ruby code that does that. This is it. You will see the code that I used on GitHub. I'll tweet the slides later so you can take a look at it in case you need more to see more about it. And that's it. That's my talk. Thank you.